In this video, we're going to start off with our first sorting technique, and that is selection sort. So before we dive into the algorithm of selection sort, let us first understand how if we are given a list of numbers, a set of numbers, we would arrange them in ascending order. So here on the screen, we have a list of 7 numbers. Now, these numbers are not sorted in any particular order. They are randomly placed, right? Now, to sort these elements in ascending order, how would think how you would do it with a pen and paper. Now, I guess the first thing that you would do is find out the smallest element from the list. Now, as I see, the smallest element from the list is 18, and you would write 18 in the first location because it's the smallest element and it should be placed in the first position because we have been asked to sort the array in ascending order, right? And then you would cross off 18 from the list and then continue with your search for finding the smallest element of the array among the remaining elements. You're not going to include 18 anymore because 18 has already been placed, right? So the next smallest element that I see is 22. You're going to cross that off the list as well, and then move on to find the smallest element from the remaining set of elements. The next smallest element is 34. Cross that off the list. The next smallest element is 38. We cross that off the list as well. Next one is 41. Cross that off the list. Then 50. Cross that, and we are left with 68, which is our largest element. Right? This is how we would do it on a pen and paper. But there is an issue, a very big issue, in fact, with this approach. What you see is that we are storing duplicate copies of elements. Right? Now, you would think, like, how does it even matter? There are just 7 elements, and a duplicate copy in total would result in 14 elements, right? So what's the big deal? You can keep duplicate copies of elements, right? But it's a problem. You see, our array here is of just size 7. But in practice, our arrays contains elements which are in crores, which contain elements in crores and millions. So then you cannot afford to keep a duplicate copy of the array because you would run out of space, right? So in practice, it is quite difficult to keep a duplicate copy of the same array in memory, and it's redundant as well, right? So this is the reason why we often don't go with this approach, like create a new array and then place elements in its correct position. What we do is we sort the array in place, meaning we do not create a new array, but we swap elements within the array and change their positions to get a sorted array, right? Now, to understand this process in detail, there are a few prerequisites that one must have. The first being you must know how to swap the content of 2 variables in memory, right? Next, you must know how to find the smallest or the largest element of the array. And then you can modify your knowledge of the second prerequisite by finding the index or the position of the smallest or the largest element of the array. Now, if you do not uh, qualify or if you do not know some of these things, don't worry. I'm going to cover them in details in the next video. So do watch them, and then you're going to be able to understand the selection sort algorithm because this algorithm heavily relies on these 3 prerequisites, right? So I'm going to see you in the next video where I'm going to show demo or demonstrate how we write the code to swap the content of 2 variables, right? So see you in the next one. Bye for now.